Hello, everyone. Just checking my sound and everything. We'll get going in a second. The reason why we want to look at the task so early is because it drives everything else afterwards. Uh, and by the way, if you can, I'm hoping you guys can hear me well enough. If you can't hear me properly, let me know. The reason we look at task is because the task and the user dictate what the heck you're actually showing. There is no point showing data if it doesn't serve a purpose. Just like there is art for art, it's sort of this art for art's sake thing. Like it's a very different philosophy in that case, right? If you build something and it's not useful, I don't want to know about it really, right? If you build a bridge and it's not used for anything, what's the point? It's a bridge to nowhere is I guess the term from the US, right? If you have data and you have if you have data and you're showing it, who cares? Ultimately somebody has to use it. There's too much data. Why you chose a particular data set, it's ultimately determined by what it's being used for. And that's where P3, where we want you to focus, but also if you take that focus, what follows from there. And this can be, people are being, maybe rightfully so, maybe, self-preservation, maybe because you don't realize what the options are. Interactivity is going to be bringing us to that. There are a world of options that you may not have considered yet. That a line graph is not the be all and end all. It's just one little part. You can do a whole lot more than that, to the point that like this, here is where interaction. I have three different graphs. They're all interacting. They'll all be connected to each other. Here is, here is a map, but it's not a choropleth map, but it is a map using different sizes to indicate some data for each of the states. Here, I could do, this would be, what is it, a banded graph, arc graph, showing the connections between different things in a network, right? Not a pie chart. Don't do the pie chart. But there's a number of different options like this that you may not have thought about. And that's the point of P3 is to expand out your horizons, expand your options, and then we're going to clip it down later. Okay, there we go. So we're going to just very, very briefly recap, and then we'll look at interaction. If we can, we're going to get to views and faceting. Faceting, a facet of a diamond, it's a side of a diamond, right? A facet is a face. It is a part allowing you to view into something. We can't see all data all at once. We are limited that way. We don't see higher dimensional spaces on a two-dimensional screen. So your job is to show one side of the data, and then maybe not from another perspective, maybe from another perspective. You don't see everything all at once. And that's what faceting is all about. You can show different parts or different sides or different views of the data, and interaction and faceting together allow you to explore the data space, see different snippets of the data at any given time, right, from different viewpoints. And if you're interacting with it, it allows you to explore the data space without necessarily just overwhelming people. And that's the thing that I think a lot of groups were trying to get to come to terms with. The lab today is not really much of a lab at all. The lab today is, I would love to give you guys advice on your project, and I wasn't able to read all of it because of the whole deadline extension. I have only got 3 of the projects so far downloaded. I'm sure you all submitted, but I only have 3 of the projects so far, so I have to look over the other 4. I'll be also doing that during the lab period of time, but I can glance at what you're doing, or we can talk about what you're working on during the lab time, and I'll parse you up into groups. Okay. So last time, when last we left our heroes, textures with the S down below, texture. Really formatting. We looked at how texture, there is a cognitive aspect to how we process the world, that certain ways of representing data, like it's easy to differentiate these two things. My visual processing system is looking for differences. It doesn't actually see everything. It finds differences. That's what it's particularly good at. And so if you do two different textures. You do different sizes, do different shapes, that sort of thing. You can easily differentiate these things. What's hard is if I have multiple dimensions changing at the same time, or I have strong angles in both cases, and I'm trying to differentiate them. So how you present the data ultimately dictates how well you can actually view or read off information from a visualization. And those are the kinds of design decisions we want you being, you know, lamenting over. We want you not panicking, but we want you carefully considering each of those particular decisions you make. Should I use this color? What color? What color scheme should I use? What kind of shape should I use? Will there be an interaction effect in there? Step by step. After you design something, then you're refining. That cleanup involves knowing all these different tricks and tactics. We also talked about Gestalt principles. We looked at proximity, alignment, common fate, and that you, by just connecting 2 points, you show that those things are related. By encircling them, you can consider them part of the same group or nested within something else. By aligning something, I say that they're all connected to each other. I also, that particular ordering, I infer order as well from this, even if I don't want to. So there's a number of different features here. So I have a connection. This is in this group. This is in this group. I have two overlapping concepts here. This is a nested hierarchy that this box is within this box. If there's a box within here, it's it's nesting like a tree, like this tree right here. That's the reason why we. Hopefully you can see my mouse on that one. Maybe you can't see there. Anyways, you see a tree. And this is what, this methodical approach to, I want to show this. What tools do I have in my toolbox? It's not guesswork. We have prearranged tools and we know why they work. Choose the right tool for the job. And we also looked at this thing, which is human suck. So essentially, we have pre-attentive processing, the ability to see things right away, 200 milliseconds that we see at a time. Like this is feature analysis. So I have short-term memory storage. I have proper perception based off of that, and I piece together my world. And then, depending on where my attention is going, it dictates how much working memory, like it dictates what I'm seeing. So my attention determines what I'm selecting, what I'm looking at, and then that goes into working memory, and that stays around for 4 to 9 seconds. And since this is so limited, I want to keep stuff on the screen, not in my head, because I can't keep it in my head. I can't track 20 objects at a time. I can track a couple objects at a time. I can get the rough approximation, but I don't want to rely on the user's memory. And if you rely on long-term memory, it's bad in a different way. It's over 30 seconds, but it's incredibly unreliable. If you don't believe me, look at the number of, this not so bad for this term for this class, but look at 1400 or 2400, right? Every single time I do an assignment, people will say, what's this? And I'll be like, it's there, right in the notes, or it's there, right in the instructions. Now, either they didn't look carefully enough because I didn't direct their attention correctly, my fault. I may not have been very clear, my fault. Or they may not have remembered, somewhat my fault again, right? They need to be able to find it again, because if you're relying on working memory, people are bad at this. That's why I don't feel bad when I forget everything, because I know people are bad at this. I just happen to admit it to myself. Okay. And we looked at at-a-glance memory content, what will attract your attention and keep your attention. We looked at titles and text being key. Do not leave your titles and your text off of your slide, off of your visualizations. It will be bad, right? That's one of the big driving things for memorability. We want at-a-glance memorability, and human recognizable objects, as long as they don't get in the way, can actually help me understand what's going on. So if you have, we had a shredding reds group, but the red light group, seeing red, no, you had another name for your group now. It was a cool name. But the red light group, you have a new name. I wish I remembered it off the top of my head. Faulty memory, see? More than 30 seconds. The red light group using red lights or red dots on like a very dark or a faded out extremely low saturation or gray map would make the red lights pop on this. And if you want to see where the red lights are, maybe the size of the red lights, the number of, the number of incidents in the city based on the number of red lights, big red stoplight. Heck, you can make it a stop sign if you wanted to, right? And make a difference, but then you have to put the word stop on it. But you can make it still an octagon, right? It's an octagon, right? You could make an octagon or yeah, it's an octagon. Uh, hexagon, hexagon. But you can make it that shape to convey what you're trying to show, or maybe it's a red light. What you're trying to do is people will recognize it and be more, remember your visualization more, remember what you're trying to get across more if you use something that's automatically readable, that they know what you're actually trying to infer. Similarly with, showing resources like pools, skating rinks, and the like, you can show a pool and a skating rink as little icons if it doesn't get in the way. Or maybe you have blue for one and yellow for the summer or something like that to show winter versus summer. Things along those lines. Uh, you're trying to convey a snowflake versus a sun for summer and winter. You're trying to do things that will help people understand without having, you're trying to reduce the amount of friction between what they're thinking and what they're seeing, right? You do not want to have them have to figure out what you're trying to say. You need to make it obvious if you can. That's one of the grand challenges. And if you can, redundancy is awesome. We'll see a bunch of cases of redundancy. So redundancy helps make sure that if you don't see it this way, you see it the other way, and you still get the same information. If you watch movies, there is a ton, and TV shows, and almost you name it. Great storytelling always involves some kind of redundancy. You don't expect someone to remember, you repeat the pattern to make sure it stays in their head or make sure they don't miss something. And they're all empirically based, by the way. Essentially, all of this information is based on empirical research. It's not just me guessing stuff. I love the 538. If you couldn't tell, one of the reasons I love it so much so is because, and I probably should update this from 2015, but the 538 is what you guys are, again, what you guys, I presume you guys are aiming for in your future careers. If you're looking at journalism and you're looking at data, these guys do it. It's like New York Times and these guys are just two of the best in the business, or at least traditionally have been. They're good because they have a lot of data and they're trying to simplify it and sort of focus on the data. So here is some of the weird charts that they made way back in 2015. So I cannot believe any human being can do this. And I would argue bad visualizations there. Now, there is an ordering effect, but notice they're using a rainbow color scheme, and their level of luminance changes at each level. Although right here, the level of luminance, if I went to black and white, you wouldn't see the difference between the Wednesday and the Thursday. So what they could have done is banded it so dark light, dark light, dark light, dark light, and use different rainbow colors to let it pop out a bit better. Fine. But this is the number of minutes that this Dan Fire, I don't even know who this person is, but I'm assuming he's the best person in the world at doing a crossword puzzle, because this is the number of minutes Dan Fire takes to solve the New York Times crossword puzzles by the day of the week. Yeah. Under 2 minutes for the Monday crossword puzzle. At most 12 minutes to do a crossword puzzle. I had 12 minutes to read the first question. Okay. But notice, so this would be one of our color maps you could end up using in here. But I'm not a big fan. I would critique some parts of this. But notice you're not trying to count this. I'm getting approximations of how much time it takes to do certain things. And notice this, all they did was stack the day of the week on top of, so I know how much time this is to do the crossword puzzle, and this number Mondays, Tuesdays, and Wednesdays above that. It's a stacked, I guess, point graph. Kobe, God rest his soul. Uh, this is Kobe Bryant shooting a regular season 2005 2006 shooting, I guess, percentage in different areas on the court, right? And so we have low versus high, and I don't know. Oh, yeah. So they have different sizes of the frequency of which they're shooting from a particular area. So he does not shoot very often from there, uh, shooting a lot from here. And this is the what's his scoring percentage is. Now, notice it's redundantly encoded 45%. Okay, 48% right there. 37% right here, right? Your color, and you've also indicated what it is from this thing. I don't know about you, but I want to know more about this, right? I look at this and I go, okay, Kobe Bryant is brutally good right here and a little bit here. If you want to make him screw up, send him off over onto the side of the court, right? This side of the court can't hit the broadside of a barn hardly. 28% better than me. But over here, even in the 3-point range on that side of the court, he is brutally efficient, right? He's meant to be over here. And they know it. And knowing this data tells you what you can actually do with it. And so what might want to do is like, what games was he shooting? Was he making these shots in? What was the ultimate score of the game? How many points was he scoring from each of these areas in total when you summed them up? What, et cetera, et cetera. I might want to explore the data in different ways. I might want to see his 2006 to 2007 season using the same approach and compare between the two of them. Maybe I want to see um, his entire career shooting percentages at different parts of the court. That's what we're talking about today. So all of this just to lead up to that point. What we're talking about today is interaction. And interaction ultimately lets me see something like this, get your attention, get the initial view, and then look for more. Instead of, so presentation, when we're talking about different tasks, presentation is often, here it is, here's the data you want. Discovery is you let the person explore until they find what they want, and then they can see it. Presentation is, and I always get a little wonky on presentation, the ability to generate a presentation versus being presented the data. They're different things, right? And it depends on how you want to slice that. If you're making a presentation for someone else and the visualization is designed to help someone design a visualization to present to somebody else, it's not presentation, it's more recording or demonstration, something along those lines. Um, nice interaction. That's an animated transition, by the way, in case you're wondering. We're going to be looking at why we use interactions. We're going to look at the Schneiderman mantra if you ever want, and people love quoting it because it's fairly simple to use as a term, but at least people are referring to the coursework. And we're going to look at basic interaction foundations that, again, you can play with. That's just a starting point. You can, you know, wiggle it and change it around a bit. Uh, I don't know if I have. All right, there we go. So one of the things is if I have complex data, I either have to throw out most of my data or I can get up interaction. I can't have both. I can't just dump data at people and say, hey, figure it out. This is hopefully I've beaten that to death, right? If I have limited perceptual effects, I have to control attention. I have the ability to limited number of pop-out effects that I can see. The only way to still use pop-out effects and still let people look at a large data set is interaction, changing the view over time. So if it's static, I have a specific story. If it's interactive, the viewer discovers a story, which is another thing. They're more invested. They're actually engaged in the content, unlike this lecture, right? The reason I put all these little in-class exercises in and why I had quizzes in my classes, because I want interaction with the class because it helps improve engagement. Uh, I can't do data exploration or insight or reasoning about, the data itself. Um, without that, right? I really want to make sure that I can explore the data set. Uh, and it makes it personal, right? You are the one controlling. It's a choose your own adventure versus the novel, right? It's if you know choose your own adventure books. The If you're just railroaded through something, it's not the same as you discovering it yourself. And you can deep dive and see things that the original designer did not intend. The baby name Voyager was just a bunch of baby names. And then people explored it for all sorts of weird, wonderful things, naming patterns over time. Nothing to do with what the original intent was. Um, it does require human time and attention. It is not something that you passively do. You cannot do interaction on a billboard either, right? Interaction ultimately requires that sit down and pay attention to this thing. Uh, and human guided, you may miss something, but it's a versus automatic feature detection versus interactive visualization. They're all different. Uh, Automated feature detection just says, here's what we found versus find it yourself. As you might imagine, some people just don't want to find it themselves. Uh, and what you're trying to find is that balance. If you can automatically find interesting things and let the person explore, but also point out where something interesting is happening, that's sort of the sweet spot. That's where we're aiming. So let the computer find some interesting stuff. Let the human explore and find other interesting stuff that they didn't think possible. Uh, that's a very difficult task, but it's what we're looking for. And as I said earlier, this actually was one of the big pieces from the three projects I've looked at so far. This was one of the big missing pieces. People are giving me, here's a line graph. Okay, but you're not exploring. You're not um, the investment group, which I'm sorry. Again, I got to make sure I memorize the cool names that you guys are coming up with. But the investment group was like, we got a ton of data. Okay, so what do you want to look at? And it ended up over and over again. It was, we have a ton of data. We don't know what the person wants to look at in terms of their investments or how they're going to invest based on COVID and things along those lines. Interactivity is the key because I might look at the retail industry and see how they're investing. I might look at food services. I might look at restaurants or entertainment industries, restaurants. Depends on how you view things. I might want to look at clothing stores, right? I might want to look at different industries, change my view. Maybe I want to change the time frame that I'm looking at. These change how I use the system, and then you can't show all that data all at once. But if I say just show me the restaurant industry during this month, and I'm going to deep dive and I'm going to look at all the different provinces of Canada versus I only want to look at Ontario for the entire year. That's very different. The user ultimately can decide that. If you can get that interactivity, you have a lot more power. By the way, marks and channels, the other part that people had trouble with. So just let me clarify a little thing because I fully appreciate it takes multiple exposures to this. I was thrilled to see people trying marks and channels so in their write-ups. So uh, the big thing I want to point out here. So here are our marks. They are the things I am putting down on the piece of paper as effectively. What did you draw on the piece of paper? I drew a dot, I drew a line, I drew an area, a bar. If you have a bar chart, you could interpret it as an area, you could interpret it as a line. It doesn't matter, but it's not both technically. I don't have an and, it's sort of a, I'm saying this is a line, right? Because the bar is only going to grow in one dimension, not both. The width isn't being varied. And so you can consider it a line, or you can consider it an area. Both would be fine. It's not both at the same time. Either or, not both. Okay. Um, and similarly, um, we had people talking about it. So tilt is slightly different than what we're talking about. Oh, we had people talk about area and length. No, if you're only manipulating one, you could just say length if you want, or just say area. It's not both really. I would go with length. If it's only changing one dimension, I'd say length. The only big problem was people were throwing a bit too much stuff at it or not. I have some people saying things like The marks were the color and the lines. And no, thank you. No. Oh, okay. My wife coming in. Sorry, I thought it was a clean. Anyways, right? You can't really. The channel is how you manipulate the mark. So it would be things like color. It might be something like shape. The I still have a point here, even if that point is a star or a triangle or a little squiggly do. It's still just a point. If that point happens, if let's say I have a point and each of these lines is a particular length and I'm measuring that particular length and that length actually means something, it's actually not a point anymore. That's a series of lines all surrounding each other. That's actually using a line. It's not a point at all anymore. It happens to be in a particular space, but it's a cluster of lines. It's just, this takes some practice to get used to. So things like, and this is where it got ambiguous, right? This would be one of the examples I gave earlier. I just stole a slide, and I'm saying there are two attributes here. We have an X position. We have position on the Y. Where it ends, I said I've circled both, but what I was trying to say here is you could call it area, you could call it a line. It's not really both. I wouldn't say it's and. It's one or the other, but you can choose either one that you want, whichever one you want. That's the word I was looking for, right? I I call it a line myself, right? Because I'm not changing the width at all. I'm just extending this way. So I would normally say a line, but you call it area. Both are fine. It's not both at the same time, effectively. And the channel, both as in the X coordinate is changing, the Y coordinate is changing, fine. I could change the color, depending on the I don't here. They're all the same color. The shape is not being changed at all. Effectively, it's still a rectangle. They're different lengths. So ultimately the shape is different. It's different lengths, but they're all rectangles. The category of shape is the same. So it's either the length or the area. So if I have a line, I say it's the length. If I have an area, I say the area changes. That's why I say it's a line with a length, because we're really effective at reading length of things, which is what we're showing here. Okay. So this is what we're going to be looking at today. We're looking at how we can arrange stuff. We can look at maps as well, things like that. And how we can look at certain things. So this is a mapping of categorical and order attributes. Okay. This is what we want to look at today. How do I manipulate my visualization to change the view and let people follow along? Because ultimately that's one of the problems that people would have is if I have one view of the data and then you suddenly took it away and plop it back up, you don't actually see what happened between those 2 points. So let me see here. If I do that, right? It's a sudden transition for you. It's really quick. You can sort of follow along because I'm saying everything has changed. But if I move stuff around to blink it off, put it back on, and don't change and just rearrange some of the stuff, you're not actually going to see what changed between A and B. I don't see what that transition is. So what I really want to do is sort of my interaction is the reason I'm setting interaction is it helps me understand what's happening, how the data is changing, how my view is changing. So we're going to look at changing over time. That would be like an animated transition. I can see from here to here what that change is. We've done that before with the D3 example, I think, for my solution. I need to make those solutions available for you guys now. So I can see how data changes over time. That allows me to change, like I can see, how something progresses. Or maybe it's a selection, me selecting these data points and then it's selecting in other places. We'll also look at for data manipulation, what data I'm looking at a time. I can navigate it either geometric or semantic. So essentially I'm choosing which subset of the data I'm looking at, the window of data I'm looking at. So I can pan and translate that. I can zoom in so I remove a lot of the other data and I'm just looking at a particular area. Or I can constrain the set and say, look, I'm not looking at anything other than this set. And that can manipulate what attributes I'm looking at. Whether I'm looking at uh, only show me see, let me think of a good example from your uh, what work you guys are looking at. I'm going to just go back to this one again. Only show me, uh, I guess the resources or municipal, free municipal items like pools, splash pads, stuff like that. Things in the summer. Remove everything else that's not a summertime event. Maybe I want to cut out, maybe I want to remove all the red light cameras that are associated that are in Alta Vista. Okay, but leave everything else. Or maybe I don't only want to see red light cameras in Alta Vista. Maybe I want to combine a bunch of data together and show it. That's projection. So here's the idea. So we're going to change things over time, which involves us how we're encoding information and how we do animated transitions. Then we'll look at selection and navigation. So this is Schneiderman's mantra. Way back in 1996, and we'll talk about the zoom filter details on demand and stuff like that. But here's the concept: 3 main points. People get overwhelmed. Give them the overview first. This makes perfect sense for vast majority of people. And yet, when we get to data, people forget this rule for some reason, right? What do you think our first lecture is in this course? Like anytime you do anything, you want to see the overview of something. You don't get into the gory details at first. You say, my project is this. Here is my, if I'm playing video games are a weird case because it's storytelling. If I'm showing a large amount of data, I want to get the overview first. It allows people to understand what's going on. You don't dive into some fiddly diddly detail. You give sort of the general view of things. Then you allow people to zoom and filter, as in you remove data that they don't want, or expand or remove the amount of data that they're seeing at a time, or filter out data based off of an attribute. And then when I need the information, then and only then give me the details on demand. I'll go over each one of those parts in a second, but in case you wondered, this is actually the research paper that really honestly wrote this. There's a published paper in 1996 where he repeats the same thing this many times in a row. It's really, I remember going like, what, who repeats themselves like this in a paper? Ben Schneiderman does, it turns out. The idea, but he's very explicit in the way you can think about a visualization. It's not some pie chart, right? If we're talking about large amounts of data, I can't show everything at once. And as a result, I need to get the overview. I need to zoom and filter, remove and change my view of the data. And then I only give details when the user asks for them. All right. So overview is a high level summary. Zoom and filter enables data discovery and exploration. I can change my perspective in the data. And details on demand. I don't want to overload the user. So the Kobe Bryant thing, if I showed every game, where it was, what it was doing, all of the data that I would potentially want to look at for Kobe Bryant's statistics playing basketball, like what game he was shooting that average from, it would completely overwhelm people. If I showed every last part of every one of those bits where these are the games that this was involved in, it would be an unruly mess. I only see it when I hover over it. It's a tool tip, and many of you made that suggestion in your projects. So here's changing over time. Gapminder. We've already looked at Gapminder, so just a reminder. I press play, and I see all these bubbles moving over time. I can see this transition over time, and I can track what is happening. Not just animated transition, it's actually can convey information. So by changing over time, it allows me to track what's changing, what's new, what's different, but also put two and two together that this country here has changed and the life expectancy has rose at this particular point in time. So I think for when you actually look at the Gapminder thing, you'll see all the countries just drop down in about, where would it be? About 1939 or so. Why? World War II, right? You can actually see the data is just boom. And some countries stay perfectly fine because they were not involved in World War II. But you'll see this big drop. If you're watching COVID, you'd probably see a drop as well for the life expectancy. I think, yeah, the life expectancy was a noticeable drop from previous years. Here would be selection. I want to hopefully show this properly. Doesn't quite. You'll when you see selection, you'll be like, yeah, yeah, and then I'll say, do you have that? Because that's what we're looking for. Okay. Uh, all right. Connecting the dots. Here we go. So you can actually look at any given person. So you can look at key strategists in the Obama administration, Clinton loyalists, Obama operatives. Just hovering over it changes what's selected at any given time. This is also effectively what's called brushing and linking, as in when I check one thing, it reflects everywhere else. Here's a pro Clinton super PAC. Notice these are clusters of people together. This, I don't know who this guy is involved in. So Clinton 96, Maya Harris, Charlie Baker. Okay, and let me see here. You can see who's connected to who. Janet Clark. Right. But notice by just hovering over things, I know how people are interrelated and what things they have in common. Fine. It's a longtime Clinton loyalist. Here's Jeb Bush. No, not involved, not involved, not involved. Sally Bradshaw is involved in a lot of different things with Bush, Romney, lifetime Republican. And you can see patterns in the data by just hovering over it and seeing who is connected to who. And if I connect it right to rise, these are all the people involved in that group. People involved in Romney 12. Selection as a means of understanding what the connection between things are. Because if I just show this without any other context, with nothing else, I'm not going to make sense of this. It's just a big bunch of lines. If I select Romney 12 and I see this, I can now see who's involved in Romney 12 and how they fit in the grand scheme of things. I can selectively choose parts of the data I'm looking at. I can put a spotlight on the data. And here's Ted Cruz. I don't know why you want to see Ted Cruz, but Marco Rubio. You can look at all of these things. Pretty fun. All right. Navigation, you've also are well aware of. This is the easiest example I can give you, right? A map. Google Maps is wonderful for navigation. I grab it, I move stuff around. I'm selecting the data set that I'm looking at any given time by moving around so I can pan and translate. I can also zoom in when I'm looking for a pizza place. It turns out not a lot of pizza places around me, so I have to zoom back out again. Or Mexican restaurants in the city. I have to zoom back out again. There's nothing around us. There's a couple burrito places that are, good Mexican restaurant. Love to know, right? Or maybe I want to constrain the space. So I'm saying I only want to look at this particular area, or I only want to look at Mexican restaurants. I'm constraining what data I'm looking at, and I can zoom in or whatever I want, but those are always visible. It's constraining based on an attribute. This is, I think, Squashing Peacocks. I don't even remember the name of the paper. It's one of those weird paper names. Uh, Ottawa native and a friend from undergrad and graduate school, now living in England, but he's from Ottawa originally. Dan Archambault, if you want to look up his name, he does graph visualization. That's what he does all day, every day. His obsession is looking at graphs. We'll look at graphs later on in the term. So that's what he does. And it turns out graphs despite being a very simple concept, are really hard to get your head around because graphs can be huge. The internet it can be represented as a graph, as in every computer is connected to which other computer, and I can map all that stuff out. And so his thing is, how do you represent immensely large graphs to show the connectivity? Because you can't show everything at once. I need to be able to zoom. So he has what's called a semantic zoom. There's no space on the internet. They're just connections between different computers. So when I zoom in to a particular node in my graph, so I zoom into this area, let's say right here, it's a fully complete graph. It's a whole lot of connections. So when I zoom out, I represent that as some other symbol. When I zoom in, I can then show the details. Semantic zoom. It's not spatial at all. It's I'm showing more details when I've zoomed in. I'm showing fewer details and maybe a different symbol when I zoom out. The It's based on the concept, not necessarily based on geography. Oh, are these people on election campaigns? They are for the various election campaigns. Tori, sorry, I didn't see your question right away. The various election campaigns for Democrats and Republicans in the United States. Yeah, I guess I keep forgetting you guys don't know U.S. politics necessarily that well. Um, for Democrats and Republicans, and what you'll see is for election campaigns, you'll get these migrating people where they'll start off with Bill Clinton's campaign in 92, and then they'll be in Bill Clinton's campaign in 96, and then they'll be in, let's say, Al Gore's campaign. They'll work on Al Gore's campaign. They're political operatives. They're people that are working their job is to help political campaigns. They're not necessarily even that political, but that's their bread and butter job. They're like bureaucrats, but they'll hop from one campaign to the other. And so they'll pick up people that are really successful in one campaign. The Obama administration was famous for that. They picked up a bunch of brand new people, and then those people got passed off to Obama when he ran for reelection, and they got picked up again for Joe Biden recently. Right? They just keep on sort of drifting around, and so you'll see the connectivity. And so yeah, you're trying to figure out who's connected to who. That person that you met one time at a dinner party, that's why that's how they got into that campaign. The weird connections. Um, and then we have this final filtering and zooming, the queries and filters. So I might want to reduce the amount of data that I'm looking at because it's overwhelming, right? This is overwhelming. And if I try and show the size of the connections in my data between my computers, or if I'm showing the amount of bandwidth going back and forth on this graph, good luck, right? It's too much information. So maybe I need to filter out or remove some of that detail and then put it back in later. So this is where attribute reduction comes in. I can remove certain attributes. So a slice is what normally I always have to look this up each time. A slice is what I'm keeping around. So a slice might be a brain scan. Slice, well, that's literally what they would use as a term for when they're doing a CAT scan of your head. They'll get a slice, the plane of data about your brain that they're looking at a time. But it might be a slice of data as in I want to only see Mexican restaurants. It's a slice. I'm keeping only Mexican restaurants being displayed. Everything else gets removed. Slice. A cut is what I take away. In this case, I'm taking away the roof of the house, right? I keep all the data in the house except the roof. I'm choosing what I'm removing. So this might be for Google Maps, I'm removing the bike path information. I'm removing traffic information. I'm things that would normally be there, I'm taking it away. That's a cut. And it's based off of the attribute again. So if I go back to this, right, I'm choosing this attribute and this all the data that has that attribute. But in this case, I am choosing everything in here and I'm removing everything that's not in the selection. So I'm sort of choosing the data set versus choosing the attribute as well. One other way of looking at it. Finally, we have a projection. Projection is comes in handy. We're not going to have time to do a lot of deep diving into this. I did a deep dive into this in my grad class. because a lot of them were doing something like multidimensional scaling. They have a course in multidimensional scaling. They looked at machine learning algorithms. A projection is something like, and I always use this example, if you have music, and music is a very complicated high dimensional space. Like you have the song name, the song artist, and you can do a text analysis. But you also have the length of the song, the genre of the song, the number of beats per minute of the song. You have the intensity of the beats in the song. You have what kind of instruments you have in the song. Um, you can break it down into a whole lot of different dimensions, very complicated dimensions. If you want to do a sound analysis, spectral analysis of the sound. So really complex data set. What if I want to compare two songs together? That's what this projection is. I can take what is effectively this immensely high dimensional space, right? The distance between two, you can say there's a distance between two songs, but it's in a really high dimensional space. And you say, no, 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 just going to represent it in 2D. So um, how similar is this song to this song? Well, I want to be able to put them on the screen in two-dimensional space. You can't accurately do that. I have to somehow scale do some math to get it represented. And it's not going to be right, but it's going to be approximately there. Or maybe I want to have, let's me give a good example. You can choose any two dimensions from your data set and say, I'm going to map it this. So this is the number of traffic violations, and this is a number of red light cameras in the area, or choose two dimensions and put it there, and put all your data on those two dimensions. Then you can change your data and get a different graph. That's a flattening. I'm removing other data that I'm not looking at, projecting it onto a lower dimensional space. Effectively, can I convert really complicated data with a whole lot of data sets into a smaller space? So the investment group, they're going to be constantly doing projections. They have a whole lot of different data sets. Which data sets are they looking at? Maybe they want, I don't suggest it, but maybe they want to take the high level space and say, okay, take all the data that we know about these different industries and just collapse it down so you can represent it in two-dimensional space. How restaurant services compares to clothing and shopping services. I don't know my industries very well, right? And I put those on two-dimensional space, not necessarily based off of particular attributes, but just how similar they are. Can I project it? Like, if I have if I'm doing hand puppets, rather than, shadow puppets, right? My hand is in a weird contorted thing. I shine a light, it makes a flat shadow. It makes a two-dimensional projection onto the wall. Uh, by the way, so I love this Ben Fry thing. I bring it up a bunch of times, so hopefully I can do it here. You guys do not have, unfortunately, 02. You don't actually have any background in zip codes, I'm assuming. Normally I would ask you guys to actually give me a zip code to type in, but 176. That's my old zip code. It's for the town of Melrose, Massachusetts. Oh, there we go. 13625. Nice. Colton, New York. Nice. Andy, are you from there, or you just know someone that lives there? Born there. Nice. I love these sorts of things. Notice, by the way, if I get rid of some of these numbers, oh, the family is there. Okay. Nice. That's the first time I've had Canadians having something like this. Notice what 1-3 gives me. It gives me a lot of upstate New York. 1 gives me New York State, right? And I think I should be able to hover over anything. So 1-3 shoots over this way. 4. I can do 1-9 and it pops you down there. If I go 1-8, I wonder what's going to get me New York City. I think it didn't give me New York City yet. 1, 5, 1, 4, 3, 1, 2, 1, 1. There you go. Of course, New York get 1, 1 out of all of those things. We want the first ones. Right? All of New York, the New York City, Long Island area is starts with 1, 1. Notice that filtering and using saturation, it's luminance in this case, allows me to filter out stuff. And if I go 9, 9, let's say, 9 is the West Coast, 9, 9, 9 through 9, 8, say Washington State, 9, 7, Oregon, 9, 6, part of California. Yes, that's neither here nor there. But it is, I can filter and I can query. I start typing in some of my query and I filter on the fly. It's a dynamic query, also invented by Schneiderman, by the way. Dynamic queries are so common nowadays, you don't realize it's something special. It's extremely special. The fact that if I'm start typing and it gives me immediate feedback, it changes how I do my query. If I had to type in all the numbers and then press enter, I wouldn't have gotten any of that information about how zip codes work in the United States. More importantly, if I was wrong, if I accidentally take the wrong number, I don't find that my fault until much, much later. It's the same as when I'm coding. If I had to wait to compile to find out when I have a syntax error, which is the old way of doing it, you'd write a bunch of code and then find out you wrote everything wrong. If I find out I have an error when I'm typing, I can change it right away. Figure out what my feedback, get my feedback right away. Oh, New York City, 11104. Oh yeah, New York City is 11. Oh, 101001. Okay, it includes one. It's both. Nice. I didn't know these things about New York City and the like. I didn't know how the zip codes were working. Same with if you look at Kayak, most of these things, they're all dynamic queries. You change a couple values, which I suggest, by the way, for your project. You change values and you get an immediate feedback so that you can play with and explore your data as you go. So when I choose a particular date, it changes what's visible here. I can change this thing here, which will filter out what data I'm seeing. Okay. So we're looking at attribute reduction. I'd like to take a brief moment, not that long, and I just threw this in last night, but I want you to find your favorite interactive visualization. Just find out you hit an interaction visualization that you liked at some point in time. I'm sure you have. Why did you find it effective? Why did the interaction help? This is not just any visualization, ones that you have to interact with. And post a link and maybe a brief little explanation in a Google Doc. Throw it on the Google Drive. Lecture 10. All right. I'm going to just hang back for a second and then we'll see what you guys come up with. Oh, here's one of my favorites, but coming from Northeastern, refugees, scholars, and the Nazi era. Weird, wonderful stuff. All right, so let me just pop this back up again so you can see what we're doing. Find your favorite visualization, post it on the Google Drive. By the way, Stephen, I think though I do love the doodle, I don't know if it's a visualization. It's interactive, but is it visualizing data per se? It's a game rather than unless it does
Oh,
something
and
cool.
it has to visualize data
Yeah, it's to
in
visualize data.
particular.
Yeah,
Okay, okay. I thought it was just like favorite form of interactivity in general, because I was gonna say the interactive element of it is why it's my favorite, and also it does provide a history of the thing. But if it
that is
has to be
awesome,
just
actually.
pure data, then I can change it.
Not pure data, but in this case, it's a game in that case.
Yeah, yeah,
That is so cool. I forgot all about this one.
yeah. It's by far my favorite doodle that they've made.
Nice. In case anyone's wondering, it's on the drive, but it's the Google Doodle for the 30th anniversary of Pac-Man. Wait, the actual just the building is the Empire State Building is 1,000 10,001. That is crazy. Okay, but still, that is cool. I love these sorts of things. Oh yeah, let's do that. I'm looking at Tori's thing right now. How to dress for space. Okay, I'll give it that. Let's see if anybody else has anything else. All right, we got some other stuff. So pass in whatever you have soon. This massive spacesuits was pretty cool so far. I'm just looking at some of the things you have so far. Oh, that's so cool. Okay, I'm gonna show all these things. Okay, so while people are posting their things, I'm just gonna go over a couple of them to make sure that we're fine for time. So how to dress for space. Now, there's the interactivity and the amount of data that's being displayed. It's more of a exploration of what things look like, but I still think it's actually really kind of a interesting approach. Um, so there's a step-by-step thing going part by part through the space for the spacesuit, gold tinted visors, oversized ski goggles. I love the person. See the face, their name is so small. They're just even trying to return the astronauts' personalities, which would be so natural now. Just a way of ginning up the interest and getting people excited about having a personal connection. Okay. Unlike this, Apollo 11 patch did not have the names of the crew members. Armstrong, Buzz Aldrin, and Michael Collins felt the names should be left off because the flight represented all of mankind. Okay. That's pretty cool. Tubes and nozzles, life support. Okay. You can do the analysis in the back. Left his backpack on the moon in order to ensure that the ascent module will well below its weight limit. The pack contained astronauts' life support system, which provided supply of oxygen. Wow. I did not know that. That is so cool. No, there, darn it, stupid ad. Uh, the little patch thing down here is I love the patches. It's so Boy Scout. Uh, it's so awesome. All right. Here's Will's, I do believe. I love this. Most unique words used by artists for the first 35,000 lyrics. And you can see who has the most extensive vocabulary in hip hop. Uh, just some really cool stuff here. Uh, okay, but is this, oh, cool. Drag your cursor. Oh, that's wild. I don't know if you're hearing what I'm playing, but I could try and make it play, but you can still try it anyways yourself. This is Citizen DJ Labs, and so you can grab and notice it's a mapping, a projection of on a two-dimensional space of various noises, and there's presumably the similarity. Notice there's a redundant color coding, despite the fact they're all grouped together. There's a redundant color encoding for things that are related. Press the mouse and move it around. Yeah, you can press the mouse and move it around, but I don't think anyone's hearing my sound. But they're all related sounds with the same color, that's really nice. All right. Um, what other things do people have? Asian powers in the U.S. Okay. Let's see what we have here. Oh, for VCs. Okay. Explore. Oh. Can you tell China? Okay. Oh. Comprehensive power, economic stability, defense work, military capabilities, resilience, economic relations. And is this a filtering? Oh, that is awesome. Oh, that is so awesome. Yeah, is the for generating sounds, by the way. I love that visualization. I don't think my sound is going through. Uh, I can look at the individual power for individual groups. And notice this is actually a glyph, both using different bands for the count of the different scores. Uh, and so each one of these things is a different dimension, all representing the one dot. So it's a glyph. It's a series of lines that you're actually determining. The line length is not actually encoding anything at all. It's just for the look of it. But the number of lines is changing. That is actually what's encoding the data. So you could actually say, but you could say the area of the shape that's there. It's a shape and it's or an area, and the because the number of bars dictate how big that area is. Oh wow, that's so cool. Oh, that's so cool. I'm going to look at this for like hours. I have to go back to it. This is awesome. Oh, and there's even a map too. Okay, that's cool. That is really cool. I'm going to be looking at your things for a while, guys. Let's see if I have something else. Species and pieces. Oh, okay. They share their struggles. Okay, and right. Okay, but the pieces themselves are just they're putting together something. It's just 30 fragments that are reforming to make different outlines or shapes. By the way, which is us doing object recognition even when we don't want to. I'm assuming it doesn't actually, the individual pieces themselves, do they have, then you can look at more data. Notice interactivity, you don't want to show all at the same time. That's pretty cool. Now, the pieces themselves, the fragments themselves, are not actually data per se. They form a just general shape, which is then being represented here. Is that the golden poison frog? Forest owlet. Okay, cool. Right, we're getting distracted by shot. I'm geeking out on all this stuff, so a bit too much. So anything else is the is there any does any gridlock in the sky? Oh, I gotta look at this one. By the way, make sure you put your names on these things. Okay. Oh wow, nice. Oh crap. I may not be able to continue reading. I want to cancel your pop-up. I may not be able to look at this. Oh, I guess I could go incognito. Um, right. Well, everyone has the workaround. And your old professor didn't even know really deal with that workaround that much. And we have a storytelling via visualization. Area close to air traffic control. Okay. I spot the area was closed planes over 3 hours. But crazy. That's wild. I don't know if you guys are seeing this properly or not, but oh, nice. But notice what we got with the interactivity there. That was not filtering or controlling the process. It was storytelling through interaction by making people go step by step. Same with the NASA one, with the spacesuit visualization or story. It's I'm going to take you on this journey, showing you different visualizations. I'm going to transition between one to the other, and I'm telling the story. I can't show all that data at once. I can tell it a bit at a time. And if I put them in sequence, I get a story. And people can actually understand what's happening over that period of time. Interactivity gives you that. And you cannot get that with some static bar chart or pie chart. Um, so that's really, I love, nice work, everyone. Okay. So there are some problems. And I'm going to make sure we get through interaction, and then I might be able to sneak into faceting it a little bit, but or just like foreshadowing it. There's some problems with interaction. One of them, it's hard to do. Okay, fine. But there was another one that was really obvious when a friend of mine actually did this particular project called EM Dialogue. It's for Emily Carr. It's the life and artwork of Emily Carr, who's a famous Canadian artist. Um, Lived Vancouver Island, I do believe. Anyways, they were trying to do this interactive exhibit, and they're doing a visualization showing Emily Carr's work, and so you can find where her work is and situating it at different times. So you're trying to get a feel for Emily Carr's life, Emily Carr's work, and how all these pieces fit together. And it's just opening a dialogue about Emily Carr. It's part of an art exhibit. Here's the weird thing about this. Uh, it really only allows one person to interact at a time. And uh, when they were looking at how people were using this thing, a lot of people were just standing back and not touching it. It clearly is able to be interacted with, and people didn't want to interact with it. The reason is when they actually started talking to people, they talked to people that were using it and people that were not using it. And one of the big things is no one wanted to look dumb. Interactivity requires you to actively do something, and if there is a learning curve for learning something else, and if it's open to the public for other people to see, like what I was doing there, right? I mean, it can be a little bit of a scary case because you don't know if you're going to make it, you're going to break something or you're going to just use it wrong. And people didn't want to look dumb if there's this big projected screen showing everyone else exactly what you're doing. It's also one person at a time. Interactivity by its definition is that. If you've played a video game with a friend, you know what the problem is, right? One person's playing, if you're not playing at the same time, right? It's one person at a time game. One person's playing, the other person's just watching. Now that's gonna be fun. I love watching speed running, but that doesn't necessarily be, it's not the same thing. Interactivity gives you a different thing. You can get lost. We call what's called desert fog effect. You can get lost as in I drill into one place, and if I don't design the visualization right, I'm I'm in some area and I go, where do I find this thing? Or I can't even find this thing. So you learn is a famous example of that. You can't find where this flag is to set to make sure that groups work, right? That makes no sense. And ultimately, for the Washington Post visualization of gridlock in the sky, it's the visualization designer who's putting a whole bunch of stuff together, right? They're putting things in sequence. If I'm in control, other than just scrolling, if I'm actively doing something and I'm selecting and changing things, the user's in control. Sounds great, but it may not match the original vision of the artist or the designer. And as a result, you can get weird stuff that you didn't expect to happen. It gets reappropriated for various uses that you don't expect. So this is EM dialog in case you're wondering. So you move the mouse over here and you get a list of all their different art pieces related to each other over a particular period of time. They were using a tree visualization, so rings of a tree to show age and number of years of life. Um, and I think each of these dots is actually an art piece, and so you can see how things are interrelated. It should have worked well, and it generally did work well. But the fact of the matter is, you get shown this kind of thing. Notice there's no title and that sort of thing. You get shown something like this, and people sort of freeze up and they don't want to play with it because playing requires sort of a vulnerability that you're not going to get otherwise. Interactivity means you have to learn things. The person has to explore things, and you don't know they're going to hit the marks that you actually want them to hit. Minor interactivity of you scrolling and just seeing the next part of the visualization, sure. But if you leave it open for people to choose things, you don't know what they're going to do. And oftentimes people could just get crippled with, oh, I don't know what I want to do with this thing. I don't know how I should explore this. And so there's this fine line between complete control, which is kind of boring, complete open, the sandboxing, if you will, right? Like a sandbox video game. You can do whatever you want, and people do stupid, crazy things. People love it, but it's hard to design as a result. And in between, there's guided storyline. Okay, the reason we need to, and the reason I want to get ahead a little bit on this thing for 5 minutes, is because we're going to be hitting some fairly long movies later on. What we're going to be looking at, the reason we have to we had to talk about interactivity is because ultimately that decides if we have different views of the data, different facets of the data. The only way to get that is with interactivity. You have to, unless you're automatically moving to the next view, it's not so fun. The person interacting with the data allows you to change the perspective on the data. So we're going to be looking at fasting, which comes in a bunch of different flavors. But the big thing is, think of it as I always use this example. I'm always wondering if I'm going to get in trouble. The famous fable of the fable story, the blind man and the elephant. Right? You don't see the whole picture. Actually, I just watched Doctor Strange recently while running, while exercising on the treadmill. So that also does the same thing. Looking through a keyhole, trying to understand the universe is what the ancient ones uh, discussion was. Right? You can't see the whole picture. You can try and expand the keyhole, but really, you're only seeing one little part of things. Same with our data. We see one little bit. And so we want to have different perspectives of that same data, and hopefully you can piece things together. The other metaphor I like to use is trying to explore the attic with a flashlight or your basement with a flashlight. You don't see the big picture. You don't see much. You see a little tiny pinpoint amount of light at any given time. You're trying to piece together everything by just shining the light in different places, trying to get a sense of where everything is. So a facet is to facet something is to split it. You would have heard the term faceting with diamonds, for example. How many facets does that diamond have? It's the edges, the sides of the diamond. So a facet, it's many sides. Normally for gem cutting, it's how many carat a diamond is. Actually, I think it's the number of facets that it has. Not just the weight or the size of the diamond, but the bigger the diamond, the more facets you can put on it. My understanding. It's been a while since I looked at diamond research. Um, but for us, we're looking at different ways of looking at that data set, a different perspective into the data. And that requires interaction. So we'll have multiple different views into the data, and I can either go one after the other, explore the facets sequentially, or I can show two different facets at the same time, but now I need to link them up so that I see that there's a connection. By splitting off those facets, by splitting off the views, I can reduce the amount of complexity, but you don't rely on working memory. Like if I show them sequentially, I have to remember what I saw in the past. If I put them next to each other, I can compare directly. I'm not relying on working memory. So I want to show you an example of faceting and this before I get going on this. So let me see if I can get a good example. Here'd be one example, a side-by-side juxtaposition. I have, here's one visualization, here's another visualization, a different part of the visualization. In one case, I'm showing African countries right here. And in this case, I'm showing the Americas right here. And I compare if they're both at the same time and they're linked, I can see one or the other in two different visualizations. Now you'd say, why don't you show both at the same time? Maybe I can't. Maybe it's hard to show both at the same time. I'm wondering if we had any of the examples that we had earlier, how many I could look at with, let me see, direction, select country, map. Oh, here's a map version of it. That's not quite what I'm looking for. Measures, data. No. Oh, we do have two facets. Here is one facet, one view of the data where all the data is in terms of uh, superpowers, where they are in the ranking system. And here is the list of all the countries, including their maps and their actual score separately. It's not the best example that I have, but at the same time, it's an example. I'm going to close this software right now. I'm just trying to think if I have a better illustration of faceting. Oh, that's the old standby. Multiple facets. Here is a view of how people are getting into the United States based off of different immigration and different quotas that they have for different countries. Here is, I can select my countries and I can see how they interact with one another when I add, is Germany right? Yeah, Germany. If I add Germany, I remove Ireland, I remove the United Kingdom. Here's the number of quotas for Italian immigrants. Here's a number of actual Italian immigrants that came into the country. It was very disproportionate. It was very biased in various ways and showing the problems with US policy at the time. I can throw in, let me see here. Can I throw in this one? Oh, Romania. Okay. They're over quota as well. The Netherlands, under quota. UK, way under quota during that same period of time. Turkey, over quota. But notice I have different views of the same data. Here's a geospatial view. Here is a view of from 1913 to 1949 of the number of immigrants into the country, the US in this case, and all the different countries that they're showing. Here is a line graph showing that same over a period of time. So time is this way. This is just all lumped together, and the number of people, and a line for each country. Just different ways of viewing the same data. And if I show them at the same time in different areas, I can get this interactivity. I can see how these things relate without just trying to clump it all into one visualization. That's what I want you to be thinking about for your project. And that's what we're going to be doing next. So the plan of attack right now, go off, have a quick snack. So I'm going to turn off the camera. We don't have an official lab right now. I just wanted time to You can bounce ideas off of me. We can discuss what you want to do for your project. I'm just going to be on the line. We can maybe do a breakout room and have me go over to the breakout room and talk to you guys if you want to chat about your project. You have the time in your schedule, and I want you to take this time to think about how you want to design your system, or if there's any kind of feedback you want. So uh, it's just meant to play with your ideas, see if you're on the right path, or get verbal feedback versus just the writing feedback that I'm going to be doing on the based on your P3 report. Okay, that was at least my plan for the lab. Okay, so I'll talk to you guys soon. I'm just going to turn off mute, and I will stop saving as well. Preparing, and then we'll pick this up in a little while.